Today we'll be talking about green roofs. Intro to green roofs. The concept of plants incorporated into the rooftops of infrastructure has existed long before its current relevance, adorning remarkable Mesopotamian architecture such as the ziggurat. However, green roofs haven't been brought to commercial use just for its aesthetic purposes, but rather more so its sustainable and self-sufficient mechanisms that contribute to the urban environment and its people. Builders and organizations today have utilized these current and future benefits to improve urban life, yet also to mitigate the environmental phenomena that threaten it. Our goal through this presentation is to weigh through the pros and cons of the green roof strategy, referencing modern-day regions that have implemented green technology, such as Singapore, to ultimately prove that green roofs are a worthwhile and potentially a necessary investment. Structure of a green roof. Green roofs exist as an extension of a typical roof system that is able to process rainwater instead of being sent down the gutter. First, the layer of growing medium, typically soil, soaks up and stores the water, vitalizing the vegetation planted into it. Through this, the rainwater can evaporate through the plants and back into the air without going through the storm draining process. Excess water filters into the drainage system where it can be stored in cups until it is brought back up through the soil and evaporates as well. Waterproofing layer above the roof helps prevent leakage. Intensive versus extensive green roofs. It is important to consider the complexity of the green roof system in relation to that of the building. Luckily, there exists a variety of options that can cater to the properties of different infrastructure. Extensive green roofing is a more lightweight option that can be implemented across many building types, since the load capacity is much smaller. Its affordability, while not imposing on load capacities, makes it a viable option for simple rainwater retention. On the other hand, intensive green roofing requires more structural support and maintenance, yet is flexible for a wider variety of plants and activities. This takes into account live loads due to public access from visitors, but is a great utilization of space for community parks or gardens.
Singapore's green roof strategy. Singapore has been constructing green buildings since 2005 and aims to have 80% of its commercial buildings become sustainable by 2030. They have been achieving this goal through green rooftops, and so far they have over 100 hectares of land, plant-oriented infrastructure spanning the cities, and continue to expand this to 200 hectares by 2030 as well. And their master plan involves 80% of buildings by gross floor area to be green, 80% of new developments to be considered super low energy, and 80% improvement in energy efficiency compared to 2005 levels for best-in-class green buildings. The country also aims to evolve a city within a garden, expressing how greenery should become the foundation of energy and resources in an urban setting. Another notable design in Singapore is the 215,000 square foot art design and media facility, ranging from 2 to 5 stories tall, and it flows beneath the sloping green roof terrain sheltering it. Opening in 2009, it cost $38 million to build and is integrated seamlessly into the cultural campus landscape. Stairs line the arches, allowing students to relax or study on the turf. The roof is maintained by automatic sprinkler systems that use harvested rainwater. US and Singapore statistics. Green roofs produce a 10% decrease in building energy use over the winter months. And US CO2 emissions per capita is 14.21 tons, while Singapore is only 9.48. And as part of the Singapore Green Plan, 43% of the country's buildings have been greened as of 2020, while for United States, around 13.8% of their commercial buildings are only considered green. Singapore is ranked 11th in commercial energy use, while US is ranked 8th, so they use more energy. Singapore is ranked 33rd in electricity consumption, while US is ranked 1st. And Singapore is ranked 49th in CO2 emissions from electricity and heat production, while US is ranked 10th. Portland, Oregon. So zooming in on the US to our local city, Adding more green roofs to the city of Portland can drastically increase the quality of living for the people of Portland. First, green roofs can absorb excess storm water, then will reduce the runoff into the Willamette River, mitigating future flood risks. Green roof will also affect the overall air quality of Portland. As a growing city, any improvements to air quality are welcome. Lastly, this will provide more green spaces for the citizens of Portland. This has shown to improve well-being and mental health.
Willamette River. Because of Portland's location along the Willamette River, we have historically struggled with floods. One example is the 1996 flood, one of the most devastating floods, flooding downtown areas, neighborhoods, and caused millions of dollars in damage. This event was caused by the rapid snow melts and heavy storms, causing the river to significantly overflow. After this event, Portland put in some safety measures such as flood control dams, flood warning systems, and yes, some green roofs. All of these measures certainly helped. Unfortunately, we still have been experiencing floods as recently as 2015. Thankfully, this time not as devastating because of our preventions from the rapid snowmelts. A significant amount of the flooding was due to the stormwater runoff into the Willamette River. If we were able to double the amount of green roof space, it would drastically reduce the chance of future floods, potentially saving millions of damage costs for the city. Drawbacks of green roofs and workarounds. While there are many benefits to green roofs, there are also weaknesses that should be taken into account. There is high initial cost to install green roofs into buildings, which may deter companies from investing. In addition to high maintenance may be needed, such as watering and fertilizing. Due to this, it would be difficult for places with drier climates to preserve the greenery. However, Singapore experiences high rainfall, which can negate the requirements of watering. Leaks in the roofing system are also prevalent concern. However, if the proper waterproofing and drainage systems are installed, this can prevent future damage. While initial cost and advanced structural measures of green roofs should be taken into account, it would also be noted that they can provide more sustainable and resourceful infrastructure for the cities around 30 to 50 years into the future.